In this video, we will learn about normal distributions and z-scores. First, I'll go over to the notes and then we'll come back to the handout. To better understand how standard deviations are used as measures of spread, we consider normal distributions. The graphs of normal distributions are bell-shaped curves called normal curves. The mean, median, and mode of a normal distribution are all equal and they're located at the center of the distribution. The shape of the normal distribution really depends on the mean and the standard deviation. Just recall that the standard deviation increases when the spread of the data is more dispersed or spread out. And the standard deviation decreases when the data is closer to the mean. Going back to our handout, under normal distributions, if a data is normally distributed, then the data values are distributed symmetrically about the mean, which is x bar. The graph of such data is called a bell curve, which is what we can see below. So here, the middle of this curve is the mean, x bar. Here's some features of normal distributions. 68% of the data values lie within one standard deviation from the mean. So in this bell-shaped curve, inside each region are percentages of data that falls inside this region. At the bottom are your scores. Beginning with the mean, if we go to the left, this is one standard deviation away from the mean. This is 2 standard deviations below the mean, and then 3 standard deviations below the mean. Most of the scores will be within 3 standard deviations of the mean. That is 99.8% of the scores, okay? So if we add up all of these percentages, you should get 100%. Now, this is common, this 99.8, but in a problem that you'll see below, this number might change, and so we'll have to change our percentages according to the information in the problem. So in example 1, suppose that a group of students took the ACT and the mean score was 22 with a standard deviation of 3. When the data is displayed in a graph, it fits the shape of a bell-shaped curve. Draw and label the curve, then use it to answer the questions. All right, so first thing is we're going to draw this curve and put the mean in. All right, that is the first thing. So we have this bell-shaped curve. The middle is the mean, which they give us 22. We're going to copy down all these percentages, use that curve, and go ahead and put in the bars for 1 standard deviation away from the mean. And we have 34%, that is 1 standard deviation lower than the mean, 34%, that's 1 standard deviation above the mean, and so forth. So 68% of the data is here within 1 standard deviation from the mean. And then we have 95% of the data here, okay? So if you take 95 and subtract 68, that's what you have left to put in these 2 regions. So if you divide that by 2, you put 13.5 in each of these regions, okay? So now we have 95% here. What's left from 95, subtract that from 99.8. So we have 99.8 minus 95, and that's equal to 4.8. When you divide it by 2, we have 2.4% that's out here. And then what's left, so if you take 100 and subtract 99.8, you get 0.2% left in the tails. Half of that is 0.1 that goes in the left and 0.1 that goes in the right tail. Okay, so that's how we got those numbers. All right, so all we need to do now is fill in the scores. The mean is 22. Since the standard deviation is 3, what we do is, I'll start over here. So we have 22, subtract 3, and we get 19. Subtract 3 again, and we get 16. Subtract 3, and we get 13. Now we'll go to the right. 22 plus 3 is 25. Add 3 again, and we get 28. Add 3, and we get 31. All right. Now what we're going to do, since we're all set up here, we took some time doing this, okay? Again, it's just copying everything from this normal distribution. And the only thing we added was the scores, the mean, and then finding out or calculating the scores using our standard deviation. Okay, now, what percent of students scored between 19 and 25? So we have 34 plus 34, which is 68%. That we could do in our head, right? The next problem, what percent scored between 22 and 28? So here we have 34 plus 13.5. You could put this on your calculator. That's equal to 47.5%. What percent scored between a 16 and 25? So we're going to add 13.5 plus 34 plus 34, which is equal to 81.5%. What percent scored above 28? So here we're going to add 2.4 plus 0.1, which is 2.5%. Okay. Example 2. Scores on a test are normally distributed with a mean of 60 and standard deviation of 10. Find the score that is 2.5 standard deviations above the mean. Right? So what we're going to do, we don't even need a graph for this or a bell-shaped curve. We can do this by hand. So the mean is 60. Each standard deviation is 10. We're going to add 2.5 of those. So 60 plus 10 plus 10 plus 5 is equal to 85. And that score should be a number that's bigger than 60 because it says 2.5 standard deviations above the mean. Okay. Part B, find the score that is 2.5 standard deviations below the mean. So we start with 60 and then we subtract 10 minus 10 minus 5. And we get 35. And that number is below 60. Part C, find the score that is 1 1/2 standard deviations above the mean. So again, each standard deviation is 10, a half is 5. 60 plus 10 plus 5 is 75. And example 3, last example, and then we're going to go to z-scores. The figure below illustrates a normal distribution for the prices paid for a particular model of a new car. The mean is 21,000 and the standard deviation is 1,000. Use the 68, 95, 99.7 rule to find which percentage of buyers paid the following. All right. Now we really need to take time setting up our normal curve here. We're given a slightly altered curve than the one we had from the beginning because the one at the top of the page said 99.8, so it's slightly different. So let's go ahead and find our percentages in each region. So 68 gets split up between 34 and 34, okay? To find out what goes here, we take 95 and subtract 68. That's what's left to go into these two regions, but we need to divide it by 2, and we're left with 13.5% in each of these regions, and that's within 95% of the data. Then we go to the next, the 3 standard deviations within the mean. So 99.7 minus 95 is equal to 4.7. That's what's left here in the outside regions. So divide by 2. That is equal to 2.35%. To find out what's in the tails, you subtract 99.7 from 100. 0.3% goes in the tails. Divide it by 2, and 1.5% goes in the left tail, 0.15% goes in the right. So you should have 100% left when, or total, when you add all these numbers up. Now we're going to, so that it took a little time to set this up, but it's really worth it because now you can really answer some questions. Another thing I want you to see is that the scores here at the bottom, these are the prices of a model of a new car in thousands. So, so notice that the mean is 21,000. Okay, so here's the number 21 and it's in thousands. The standard deviation is 1,000. So if you add 1,000, you get to 22 and you keep adding, right? And then on the left side, we subtract 1,000 each time. All right, so part A. Use the rule to find what percentage of buyers paid between 19,000 and 23,000. So I'm looking at this number 19 and going up to 23. The regions are 13.5. Go ahead and put this on our calculator. 13.5 plus 34 plus 34 plus 13.5. And that's equal to 95. And you can see that we could go straight up here, right? Because it's an equal number of percentage from the mean. And so it corresponds to this 95%. What percentage of buyers paid between 21,000 and 24,000? So we're only on the right side or the right half of the mean, okay? And now we are not including the percentage out to the right here, okay? So we need to add 34 plus 13.5 plus 2.35. And we get 49.85, which rounds to 49.9. Another way of doing this is to take half of this 99.7 and you'll get the same answer. Find the percent of buyers that paid less than 19,000. So here we add 2.35 plus 0.15. And we get 2.5%. Okay, so we're done with normal distribution and finding scores within a certain standard deviation from the mean, and what percentage of scores are within certain standard deviations from the mean. Now we move on to z-scores, which tell you the position of scores. So the z-score corresponds to how many standard deviations a score is away from the mean. In example 4, the mean weight of newborn infants is 7 pounds. The standard deviation is 0.8 pounds. Find the z-score. So the z-score is equal to the data minus the mean divided by the standard deviation. So the data here is, let's see, is 7.8. They give it to you here, right? So the data is 7.8. We're going to subtract the mean, which in this problem is 7 pounds. And then we're going to divide it by standard deviation, which is 0.8. So 7.8 minus 7, enter, divided by 0.8 is equal to 1. So this score here, the 7.8, is one standard deviation above the mean. That means it has a z-score of 1. Let's do 6.2. So we have 6.2 minus 7 divided by 0.8. That's equal to -1. So the 6.2, the weight of this newborn, has a z-score of -1, which means that this newborn is one standard deviation below the mean. A newborn with the weight of 7. Now, if you notice, 7 is actually right there at the mean. So when you subtract 7 minus 7, we get 0, and 0 divided by 0.8 is also 0. So this newborn with a weight of 7 has a z-score of 0, which means that it is 0 standard deviations away from the mean, which makes sense because it equals the mean. 9. All right, now if you notice, when they give you some scores, you're going to get z-scores that are negative and positive, or 0. Okay, so if you get a 0, that means that the score is the mean. If you get a negative number, that means that this score is below the mean. And that makes sense because the mean is 7. So an infant that had a birth weight of 6.2 should have a negative z-score. And an infant that was greater than the mean, had a 7.8, should have a positive z-score. All right. So an infant that was born 9 pounds should have a positive z-score because it's above the mean. Let's calculate. 9 minus 7 is 2. 2 divided by 0.8 is 2.5. So an infant with birth weight of 9 pounds has a z-score of 2.5, which means this infant is 2.5 standard deviations above the mean. An infant that was born 6 pounds, the z-score is 6 minus 7 divided by 0.8, which is -1.25. This is a negative z-score because this birth weight is lower than the mean. Okay, so when you're calculating the z-score, always start with the data itself, that's x, then subtract the mean. Sometimes you'll get a positive number, sometimes you'll get a negative number, and then divide by the standard deviation. All right, in example 5, a set of data items is normally distributed with a mean of 60 and a standard deviation of 8. Convert 57 to a z-score. So again, using the formula, a z-score is x minus x bar divided by s. X here is 57. X bar is 60. Standard deviation is 8. So we subtract and we get -3 divided by 8, which is -0.375. So the 57 has a z-score that is -0.375. That means it is -0.375 standard deviations away from the mean, which is 60. Example 6. This is our last one. Intelligence quotas, IQs, on 2 different tests are normally distributed. Test A has a mean of 100 and a standard deviation of 18. Test B has a mean of 100 and standard deviation of 15. Using z-scores, determine which person has the higher IQ, an individual who scores a 127 on test A or an individual who scores 134 on test B. Okay, now it's asking which person has a higher IQ, and the problem is we have 2 different tests and test A has a mean and standard deviation that's different from test B. So we cannot simply compare the 2 scores because we're talking about 2 different tests. Okay, so what we do is find out how these scores are, find the z-scores for each of these numbers and compare the z-scores. Let's talk about the z-score for test A. So to calculate, we get x minus x bar over s. So 127 minus 100 divided by 18 is 1.5. So the z-score for 127 on test A is 1.5. The z-score for 134 is 134 minus 100 divided by 15. And that's 2.27. So it looks like the person who got a 134 in test B scored higher than the person in test A. And not because that 134 is bigger than 127. It's because their z-score is larger, okay? So that's it for 12.4, and that's it for the chapter. So you should be able to go on to test 4, which covers chapters 11 and 12. If you need any help, please send me an email. I'll be happy to work with you. And you can also set up an appointment or call me. Have a wonderful day.